Today we're going to work on simplifying radicals. We use radicals a lot in our chapter 8 in geometry, so we need to be able to refresh our memory, I guess, on how we simplify and multiply and divide radicals so that we're ready when it comes up in geometry. Now, also, to get any credit on this edpuzzle, you do have to have work. You have to be working the problems, not just making me do all the work. So you need to, before you keep going in this video, you need to pause, go get paper and pencil. That's what you will turn in. All the problems I'm doing, plus all the problems that you're doing, you should have on paper showing how you reduce radicals. Don't forget, don't get lazy or you don't get any credit. Go get that paper. So here are some examples. Now, I've made a list over here on the right. This is a very important list right here. When you're talking about square roots, you need to be aware of what your list of perfect squares are. These are all perfect squares because I can take a number and square them. 4 is really just a 2 squared. 9 is a 3 squared, and so forth. All right, so what that means is that since they are perfect squares, they will square root very nicely. If you take one of those perfect squares and you put it underneath the radical, that square root means, hey, what's the number you can square to get that? So when I look at this first one, what's the number that I could square to get 36? Right? Well, I could square 6. And that comes out as a whole number. If you can get a perfect square underneath the radical, it's going to simplify to a whole number, and that is our goal. So when you look at this second one, the square root of 100, all right, 100 is in our list down here. So it's a perfect square, so there's a number that squares to get 100. It's 10. Now if you look at this third example, I have a square root of 6. 6 is not in my list of perfect squares, so it's not going to come out as a nice whole number. It's going to stay a square root of 6. There's nothing I can do with that. Now we're going to look at some numbers that don't fall in the list of perfect squares, but that I could break down into part of it might. So what I'm going to do is take this first example, square root of 44, and I'm going to think, okay, I look over here at my list of perfect squares and try to decide which one of these numbers over here goes into 44. It can multiply into 44, and 4 would. I'm going to break this down. I always break it down square root, and I'm multiplying these two radicals together, and I'm going to say 4 times 11 gets me a 44. Now, if I keep them both underneath the radical, that's why I get the square root of 44. The point, though, is that this square root of 4 that I chose, that's going to come out as a whole number. That's 2. The square root of 11 stays underneath the radical. Let's try square root of 50. I look in the list over here on the right and say which one of these perfect squares can multiply by something and get into 50. And hopefully you're seeing a 25. So I'm going to break it down to a square root of 25 times a square root of 2. That would get me 50. 25 times 2. I chose the 25 because it comes out as a whole number, and then the leftover part gets stuck in the radical still. All right, 32 is a little bit tricky because it's very tempting to select 4 as the perfect square that goes into it, but 4 is not the largest perfect square, so it would be like I'd sort of be reducing, but not really reducing as much as I could. So be sure to pick the highest perfect square. I believe 16 will go into that. All right, so I'm going to let you do this one on your own. Do your square root, put in your two numbers, and you tell me what the answer is. All right, should have chosen 16 and 2. The square root of 16 is a whole number. The square root of 2 stays put. I'm going to add a twist to it here. I'm going to throw a coefficient out in front of that radical. Well, that coefficient's just being multiplied, so it's just one more thing we're multiplying. I would take my 7, and then I'd work on my square root of 8 and decide what's the perfect square that goes in there from my list. And I know that 4 goes into 8 times 2. That's how I get to 8. All right, that 7 just hangs out front, and I keep reducing the radical part the way that I've been doing. The square root of 4 comes out as a whole number. That's just 2. And then the square root of 2 has to stay underneath the radical. Now, since I'm just multiplying these things, I'm going to go ahead and take that 7 times that 2. I was able to pull that number out of the radical, and it went from an 8. Now it's clear down to a 2. So I have reduced what's inside the radical. All right, let's try this next one together. Now, I should mention that just as a reminder, you should be writing these problems down on paper. If you're going to get credit for doing the edpuzzle, you have to actually do the problems on paper and turn that in to me. Just a reminder, showing some nice work. All right, so do this one with me. Write 5 root 18. And then I'm going to leave the 5 and do square root, and I'm searching for a perfect square from my list over here that would go into an 18. Okay, well, it's got to be smaller than 18 if it's going to divide into it. So when I look at this list right here, 9 goes into 18. So I'm going to put a 9 times 2. And the point that I chose 9 is because it comes out as a whole number. The square root of 9 is 3. The square root of 2 stays put. Now I have 2 whole numbers out in front. I can go ahead and multiply those together. And there's my final answer. All right, so the next one that I want you to write on your paper is this 6 square root of 24. Go ahead and simplify that one, and then answer it in the edpuzzle. All right, hopefully you did 6 square root, decided that 4 went into 24 6 times. The 6 stays put. The square root of the square root of 4 is a 2. The square root of 6 stays there. 6 times 2 is 12. Square root of 6. This is what I'm hoping you chose as your answer. All right, so we're just going to practice some more of those. I'll kind of get you started maybe, and then turn you loose. Maybe I'll make you do it by yourself. Let's do this 3 root 90. 3 square root. How about if we do this? Can you just answer in the edpuzzle, what's the perfect square that goes into 90? All right, I believe it is 9 times 10. Gets you 90. So 3 times the square root of 9 is 3, so that also gets me a 3, and the square root of 10 stays there. 3 times 3 is 9, square root of 10. All right, that's how that would reduce. All right, let's do this next one. Let's go to the edpuzzle and answer, what do you think the biggest perfect square that goes into 500 is? 25 goes in it, but that's not the biggest. You should be choosing 100. And remember that you put the perfect square part first, and then 100 times 5. All right, can you go ahead and finish that one out? You should have 40 root 5 for an answer. All right, next problem. Can you do this one from scratch, all on your own? You should have the original problem written, and then this is how you should break it down on your paper. And then that square root of 4 is just a 2. And then you still have your square root of 7 sitting there. 2 times 2 is 4, square root 7. This is what hopefully you chose. All right, now we're going to move on. Let's try something else. Let's try multiplying radicals together. All right, so this is kind of the opposite. Instead of taking one radical and breaking it down into 2, I've already got 2. I'm going to merge it back together. So I have a square root of 8 times a square root of 2. That's just a square root of 16. And then what I'm looking to do is try to simplify that radical after I've merged it together and made a bigger number. Does it reduce? And what do you know? The square root of 16 actually is a perfect square, so it's going to come out as a nice whole number. I don't even have a radical left in my answer. All right, so do this for me on this next problem. Well, let me do this one, sorry, because I want to talk about these coefficients. Now I stuck some coefficients in front, and the rule is that you can multiply numbers that are both outside the radical, and you can multiply together numbers that are inside radicals, but you can't like mismatch it. So I can take the 2 times the 5, that's a 10. And I can take the 20 times the 3 because they're in the radical, but they stay in the radical. So it'd be 10 root 60. And then remember that our goal is after we merge it together, we're hoping to re-break it down, but we want to break it down better than it was. I don't want a 20 and a 3 because those aren't from my list of perfect squares. I have to find a different number that goes into 60. And you may or may not know that. You can play around on your calculator with some numbers. 4 actually goes into 60 15 times. All right, finish that one up. Tell me what you get. You should have 10 times 2 times the square root of 15, which ends up being 20 root 15. All right, notice on the next one of the numbers has a coefficient, the other does not. If there is not a coefficient on your radical, we just assume it's a 1. We never write that, but we just assume it has a coefficient of 1 there. All right, why don't you go ahead and just tell me what you get after you multiply them together. Don't try to reduce it yet. Just multiply them together. Tell me what you get. All right, we multiply the outside parts, the coefficients, and then we multiply the inside parts. You get 50. Okay, so now I'm going to have you go ahead, finish this one out. Again, you're writing these all on paper. Reduce that and answer what the most simplified version is in the edpuzzle. I chose 25 as the perfect square that goes in there, and 25 times 2 is 50. So 2 times, remember we put the perfect square first because it comes out as a whole number. Square root of 2 is going to stay there. Your final answer should be 10 root 2. All right, so we have a few more of these. How about if you try this first one? Can you multiply those together and then reduce the radical? Okay, when you multiply them, you get square root of 18, but I'm going to re-break them down, and I'm going to break them down to something better, something from my list. 9 is in the list, 9 and 2. I think we did square root of 18 a minute ago. All right, so you should have 3 square root of 2 as your final answer. All right, go ahead and try the next one. You should have 20 square root of 20. Now I'm going to break down this radical, leave the 20 out front, break down the radical with what goes into 20, and I believe 4 goes into 20 times 5. The square root of 4 is just 2. And then I get to multiply those together to get a 40 root 5. All right, you have one more to do. Multiply these together and then break down the radical. Right, there is no coefficient on the second radical, so I assume it's a 1. So it's just going to become a 3. Square root of 2 times 14 is 28. And then I look to reduce that square root of 28. What's the perfect square that goes into 28? Should be 4 and 7. Then you pull out the perfect square part because it comes out nice. Leave the radical part in there. Final answer should have been 6 root 7. All right, we're getting close to, well, I say we're getting close to done. We're going to do some division. Then we'll be done. All right, so the thing with division, there's a couple things that we want to address. So I have a few slides on this one, on this division. The first thing that I want you to know that you can do, in the same way that you can multiply radicals together, you can also divide radicals. when I look at this root 15 over a root 5, think of it almost like if it was just a 15 over 5. That would reduce. 5 goes into both of those, so I would divide them each by 5. And I want to do the same thing. Oh, and then I should probably also mention that I probably wouldn't write my final answer as a 3 over 1. There's no sense in writing that as a fraction. 3 over 1 is just 3. So that same holds true even if there's like a square root or something on that 1, it goes away. All right, so let's look at our 15 and 5. We said that it reduced by 3 and 1, so that's what I'm going to do. It is going to reduce by 3 and 1. But since they're in the radical, I have to leave my 3 and 1 in the radical. So it would look like that. But this part right here was the thing I was talking about. Like, it's not necessary to write a square root of 1. That's just a 1. So my final answer should be square root of 3. Final answer. All right, so the first thing that we look is try to reduce our radicals because that can make your numbers get a lot smaller and be easier to work with. The other thing that we have with fractions is we're kind of particular about having radicals left on the denominator. We don't want to have an irrational number in the denominator, so we do what we call rationalizing the denominator. And what we're going to always do is multiply by the exact same radical that we see in the denominator. But to keep it balanced there, you got to do it on the top and the bottom. All right, I multiply across on the top, 6 times 5. That's going to get me a square root of 30. And in the denominator, we hand-picked the square root of 5 because the square root of 5 times the square root of 5 leads me into a perfect square of 25. And the square root of 25 is just 5. Now, I'm not going to go through this whole process and then to this process every time. I need you just to recognize, hey, if I multiply identical radicals, I'm just going to get that number. And it's not going to be in the radical anymore. I just rationalized it. All right, now I cannot reduce this square root of 30 and this 5 because the root 30 is in the radical, whereas the 5 is not. So I'm done. I would check to see if the square root of 30 breaks down, but it doesn't. All right, so I got one more of these and then I'm going to turn you loose. What is it that you think I need to multiply the top and the bottom by? All right, I should be multiplying by what's in the denominator. You should be choosing square root of 3. On the top, I have that coefficient out in front, but the radicals I can multiply. That's going to be a square root of 15. And the denominator, a root 3 times a root 3, remember, that just becomes a 3. Now, what was different here is I threw this coefficient on there. Do you see, though, that after I've simplified that a 3 in the numerator and a 3 in the denominator can cancel? So then my final answer is the square root of 15. Let's see what you can do with some of these. I've got a square root of 18 and a square root of 6. Can you try to reduce that? Remember, you try to divide first before you worry about rationalizing the denominator. Give that one a shot. Tell me what you get on that first one. 6 actually goes into the 18. So 6 goes into 6 once, 6 goes into 18 3 times, but these are in the radical. So it's going to end up being a square root of 3. And then I'm not going to mess with putting it over a 1. It's just square root of 3. Final answer. All right, so on the next one, it looks like my root 5 and my root 2, that's not going to divide out. So why don't you go ahead and rationalize your denominator? All right, so you should be multiplying by root 2 and root 2. Always multiply by the same thing on the top and the bottom. On the top, I'll have an 8, and then the two radicals multiply together. In the denominator, root 2 times root 2 is 2. And then I look to do one more set of reducing. 8 divided by 2. Those are both outside the radicals, so they are allowed to reduce. My final answer would be a 4 root 10. All right, one more for you to put on your paper here. I've got a 2 root 11 over root 2. I would look to see if the radicals reduce. I don't think they do. So then you're just going to jump in and start rationalizing your denominator. All right, you should be multiplying by a root 2 on the top and the bottom. The top you have 2 square root of 22. In the denominator, I'm going to have a 2. These 2's would cancel. And when I look at my list, I don't think anything goes into 22. So I'm left with square root of 22 for my final answer. All right, we're just going to keep practicing this division thing. So when you look at this root 8 and root 5, I don't think that's going to reduce. So I'm just going to jump in and start rationalizing the denominator. Okay, go ahead and multiply that together. That's a square root of 40 over 5. And now hang on a second. This didn't happen earlier. I have a square root of 40. I think the square root of 40 could actually simplify. I think I can reduce that. So sometimes in the process of rationalizing, you build your numbers up big enough that you can reduce them. So I'm going to change this to a square root of 4 times a square root of 10 over that 5. And the square root of 4 is a 2. And then I was hoping for something great to reduce here, like the 2 and the 5, but they don't. I can't reduce the 5 and the root 10 because one's in the radical and one's out. I think I'm done. It's not super pretty, but that's okay. All right, on this next one, I do have a 6 and a 2 that are in radicals that I think can reduce. So I don't want you to forget that, so I throw it in every once in a while to still look to reduce. So this 2 and this 6 can reduce to a 3, and this would be a 1, which means that denominator is going to go away. Sometimes you reduce, and then you still have to rationalize. In this case, the denominator goes away, and I have a 2 square root 3. All right, next one's on you. Write it down on your paper. Submit your answer. All right, what I would do on this is I'd get my numbers smaller. I'd reduce the 6 and the 10. 2 goes into both of those. All right, I don't think anything else can reduce, so then I'm ready to go and rationalize that denominator. So I'm going to multiply by root 5 over root 5. In the top, I'll have that 3, but then the radical 3 and the radical 5 get to multiply. And in the denominator, I just am left with a 5. All right, we go. Last slide. How about if you try all of these all on your own? Look to reduce your numbers, then look to rationalize your denominator. So we'll do them in parts. Do the first one all by yourself, and then we'll stop and look at what the answer is, and then we'll keep going. Okay, on the first one, I chose to reduce the numbers to get them much smaller, and when I do that, I'm left with a square root of 3. There is no denominator. Okay, you try number 2 here. Write it on your paper to get credit. You got to have it on paper. All right, so the 6 and 5 don't reduce, so I'm going to multiply by the root 5, and I'm left with a square root of 30 over 5. That does not reduce. You'd think the square root of 30 breaks down, but it doesn't. We're done right there. All right, very last problem. You do this next one all on your own. All right, it does not reduce, so I go ahead, oops, lost my pen, and I'm going to multiply by the root 3 on the top and the bottom. I'm left with a 3 square root of 15 on the top, and on the bottom, root 3 times root 3 is just a 3. Now this time, I got lucky. These 3's here can divide out. The square root of 15 is not going to reduce, so it stays square root of 15. All right, well, hopefully you're getting better and better at this and that you are ready to do some serious reducing of radicals.